NEC Section 680.22 addresses the required clearances for pool lighting fixtures. Firstly, pool lighting fixtures must be installed no less than 5 feet horizontally from the inside wall of the pool. Secondly, pool lighting fixtures must be installed at least 12 feet vertically above the maximum water level. This requirement applies to both residential and commercial pool installations. Therefore, this requirement applies to pool lighting in a condo building, even if the pool is located above the first floor. If corridor lighting is located less than 5 feet from the inside wall of the pool or less than 12 feet above the maximum water level, it may not be compliant with NEC Section 680.22. In this case, it may be necessary to relocate the corridor lighting or install it in a way that meets the code requirements. For high-rise buildings with pools located on upper floors, special considerations may be necessary to ensure compliance with NEC Section 680.22. This may include the use of hanging fixtures, light poles, or other solutions to meet the required clearances. In addition to complying with NEC requirements, it is also advisable to consider additional safety measures to prevent electrical accidents involving pool lighting. Use fixtures that are specifically designed for wet locations. Ensure that all electrical connections are waterproof and secure. Install a ground fault circuit interrupter or GFCI to protect against electrical shock. The NEC, or National Electrical Code, provides specific guidelines for the safe installation of electrical systems. Article 680 of the NEC covers swimming pools, fountains, and similar installations. Within Article 680, Section 680.22 specifically addresses the requirements for lighting and receptacles in and around swimming pools. Understanding and adhering to these requirements is crucial to ensure the safety of individuals using the pool and to prevent electrical hazards. The 5-foot horizontal clearance requirement from the inside wall of the pool aims to prevent individuals from easily reaching lighting fixtures while in the pool. This distance minimizes the risk of accidental contact with electrical components. The 12-foot vertical clearance requirement above the maximum water level further reduces the risk of electrical shock. This height ensures that lighting fixtures are well out of reach of individuals in the pool and protects them from potential water contact. When applying these requirements to commercial buildings, it's important to consider the unique challenges presented by different building designs. For instance, in high-rise buildings with pools located on upper floors, the placement of lighting fixtures may require creative solutions to meet the required clearances. This could involve using specialized mounting techniques, such as hanging fixtures or light poles, to achieve the necessary distances. In situations where existing lighting, such as corridor lighting, is located too close to the pool, it may be necessary to relocate the lighting or modify the installation to comply with the code. This could involve moving the fixtures further away from the pool or raising them to meet the vertical clearance requirement. In addition to meeting the specific clearance requirements outlined in NEC Section 680.22, it's also essential to use fixtures that are specifically designed for wet locations. These fixtures are constructed with materials and designs that can withstand exposure to moisture and prevent water from entering the electrical components. Furthermore, it's crucial to ensure that all electrical connections are waterproof and secure. This involves using appropriate connectors and sealing techniques to prevent water from coming into contact with the wiring. The use of a ground fault circuit interrupter, or GFCI, is another critical safety measure for pool lighting. A GFCI is a device that detects ground faults, which are electrical leaks that can occur when current flows through an unintended path, such as water. When a ground fault is detected, the GFCI quickly shuts off the power to the circuit, preventing electrical shock. By installing a GFCI can significantly reduce the risk of electrical accidents in and around the pool. When installing pool lighting, it's important to consult with a qualified electrician who is familiar with the NEC requirements and local codes. A qualified electrician can assess the specific conditions of the installation and recommend the appropriate lighting fixtures, wiring methods, and safety measures to ensure compliance and safety. Regular inspections and maintenance of pool lighting are also essential. Over time, wiring and fixtures can deteriorate, increasing the risk of electrical hazards. Regular inspections can help identify potential problems early on, allowing for timely repairs and replacements. Proper maintenance, such as cleaning fixtures and tightening connections, can also extend the lifespan of the lighting system and ensure its continued safe operation. In summary, understanding and adhering to NEC Section 680.22 is crucial for ensuring the safety of pool lighting installations in both residential and commercial settings. By following the clearance requirements, using appropriate fixtures and wiring methods, and implementing safety measures such as GFCIs, you can minimize the risk of electrical accidents and create a safe environment for pool users. Remember to consult with a qualified electrician to ensure compliance with all applicable codes and regulations. The NEC is updated regularly, typically every 3 years, to reflect advancements in technology and address emerging safety concerns. Therefore, it's important to stay informed about the latest edition of the NEC and any local amendments that may apply to your area. By staying up to date on the latest codes and regulations, you can ensure that your pool lighting installation meets the highest standards of safety and compliance. The requirements of NEC Section 680.22 are essential for preventing electrical shock hazards associated with swimming pools. Electrical shock can occur when a person comes into contact with energized electrical components while in or around the water. The presence of water significantly increases the risk of electrical shock because water is a good conductor of electricity. The human body is also a good conductor of electricity, so if a person comes into contact with energized electrical components while in the water, the electricity can flow through their body, causing severe injury or death. The clearance requirements in NEC Section 680.22 are designed to keep electrical components out of reach of people in the pool, minimizing the risk of accidental contact. The 5-foot horizontal clearance prevents people from easily reaching lighting fixtures from the edge of the pool, while the 12-foot vertical clearance keeps the fixtures out of reach of people in the water. In addition to the clearance requirements, NEC Section 680.22 also specifies the types of lighting fixtures that are permitted for use in and around swimming pools. Only listed and labeled lighting fixtures that are specifically designed for wet locations are allowed. These fixtures are constructed with materials and designs that can withstand exposure to moisture and prevent water from entering the electrical components. The NEC also requires that all electrical equipment used in and around swimming pools be properly grounded. Grounding provides a path for electricity to flow safely back to the source in the event of a ground fault. A ground fault occurs when electricity leaks from an energized conductor to ground. If a person comes into contact with a ground fault, the electricity can flow through their body, causing electrical shock. Grounding provides a low-resistance path for the electricity to flow back to the source, preventing the person from being shocked. In addition to grounding, the NEC also requires the use of ground fault circuit interrupters, or GFCIs, in swimming pool circuits. A GFCI is a device that detects ground faults and quickly shuts off the power to the circuit. GFCIs are very sensitive and can detect even small ground faults that may not be enough to trip a circuit breaker. GFCIs are required for all receptacles within a certain distance of the pool, as well as for lighting fixtures and other electrical equipment. The installation of swimming pool electrical systems must be performed by qualified electricians who are familiar with the NEC requirements and local codes. Qualified electricians have the knowledge and experience to install electrical systems safely and correctly. They also know how to test the system to ensure that it is working properly and that it meets all applicable codes and regulations. Regular inspections of swimming pool electrical systems are also important. Inspections can help identify potential problems early on, before they become serious hazards. Inspections should be performed by qualified electricians. During an inspection, the electrician will check the wiring, grounding, GFCIs, and other components of the electrical system to ensure that they are in good working order. The electrician will also look for any signs of damage or deterioration. If any problems are found, the electrician will recommend repairs or replacements as needed. By following the NEC requirements and taking other safety precautions, you can minimize the risk of electrical shock hazards associated with swimming pools. This will help to ensure that everyone can enjoy the pool safely. Remember to consult the latest edition of the NEC and any local amendments that may apply to your area, as codes can change. The NEC, under Article 680, outlines stringent requirements for swimming pool electrical systems, emphasizing equipotential bonding. Equipotential bonding involves connecting all metallic parts within and around the pool to create a common electrical potential, minimizing voltage differences that could cause electric shock. This includes the pool reinforcing steel, metal conduits, and any metal within a specified distance of the pool. Section 680.26 details these bonding requirements, stressing the use of a solid copper conductor sized according to the code. Proper bonding ensures that if a fault occurs, the voltage is distributed evenly, reducing the risk of a dangerous shock. Furthermore, the NEC mandates specific wiring methods for pool electrical systems. Wiring must be installed in conduit, typically rigid metal conduit or electrical metallic tubing, buried at a minimum depth as specified by the code, often 6 inches or more depending on the application. Direct burial cables are generally not permitted for pool wiring due to the increased risk of damage and potential ground faults. The use of approved fittings and connectors is also crucial to maintain watertight connections and prevent corrosion. Moreover, the NEC addresses the placement of junction boxes and transformers associated with pool lighting and equipment. Junction boxes must be located at least 4 inches above the ground or pool deck and must be accessible for inspection and maintenance. Transformers used to supply low-voltage lighting systems must be listed for pool use and installed in a dry, well-ventilated location. The NEC also provides guidelines for the selection and installation of underwater lighting fixtures. Underwater fixtures must be listed for this purpose and must be installed with a low-voltage transformer that is located a safe distance from the pool. The fixtures must also be properly grounded and bonded to the pool's equipotential bonding system. Regular maintenance of pool electrical systems is crucial for ensuring continued safety. This includes inspecting wiring, connections, and equipment for any signs of damage or corrosion. GFCIs should be tested monthly to verify their proper operation. Any faulty equipment should be repaired or replaced immediately by a qualified electrician. Remember that local codes and regulations may have additional requirements beyond the NEC. Always consult with your local building department or a qualified electrician to ensure full compliance. Staying informed about these codes and regulations is crucial for maintaining a safe and enjoyable swimming pool environment. The use of corrosion-resistant materials is also essential in pool electrical installations. Pool water often contains chemicals such as chlorine that can corrode metal components. Therefore, it is important to use materials that are resistant to corrosion, such as stainless steel or plastic, for wiring, conduit, and other electrical equipment. Proper selection of materials can significantly extend the lifespan of the electrical system and reduce the risk of failures caused by corrosion. Additionally, the NEC addresses the requirements for the separation of communications wiring from pool electrical systems. Communications wiring, such as telephone or data cables, must be separated from pool electrical wiring by a specified distance to prevent interference and potential hazards. The NEC also provides guidelines for the installation of pool covers and associated electrical equipment. Pool covers must be properly grounded and bonded to prevent electrical shock hazards. Any electrical equipment associated with the pool cover, such as motors or controls, must be installed in accordance with the NEC requirement. The NEC also covers the requirements for the use of solar photovoltaic, or PV, systems in and around swimming pools. Solar PV systems must be installed in accordance with the NEC Article 690, which addresses solar photovoltaic systems. The NEC provides guidelines for the location, wiring, and grounding of solar PV systems to ensure safety and prevent electrical hazards. It's important to have a thorough understanding of electrical principles. Voltage is the electrical potential difference between 2 points in a circuit measured in volts. Current is the flow of electrical charge, measured in amps. Resistance is the opposition to the flow of current measured in ohms. Ohm's law states that voltage is equal to current multiplied by resistance, or volts equals amps times ohms. Understanding these basic electrical principles is essential for safely working with electrical systems. Safety precautions are crucial when working with electricity. Always turn off the power at the circuit breaker before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment, such as rubber gloves and safety glasses. Never work on electrical equipment in wet conditions. If you are not comfortable working with electricity, hire a qualified electrician to do the work. Proper planning is essential before starting any electrical project. Determine the load requirements of the equipment you will be using and select the appropriate wire size and circuit breaker rating. Obtain all necessary permits and inspections before starting work. Following these steps will help to ensure a safe and successful electrical project. The NEC provides guidelines for calculating the load requirements of pool equipment, such as pumps, heaters, and lighting. The NEC specifies that the load requirements be determined by electrical engineers. It is required to calculate the total load of the equipment and select the appropriate wire size and circuit breaker rating to handle the load. The NEC also addresses the requirements for the overcurrent protection of pool electrical systems. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. The NEC specifies the types and ratings of overcurrent protection devices that must be used in pool electrical systems. It's important to know the dangers of backfeeding electricity into the power grid. Backfeeding occurs when electricity is generated by a source, such as a solar PV system, and fed back into the utility grid. Backfeeding can be dangerous because it can energize utility equipment, such as transformers, even when the power is turned off. This can create a shock hazard for utility workers. The NEC provides guidelines for preventing backfeeding, such as requiring the use of anti-islanding devices that automatically disconnect the solar PV system from the grid in the event of a power outage. Proper documentation is crucial for all electrical work. Keep detailed records of all wiring diagrams, equipment specifications, and inspection reports. This documentation will be helpful for future maintenance and troubleshooting. It is also important to label all electrical panels and circuits clearly. Proper labeling will help to prevent confusion and ensure that the correct circuits are turned off for maintenance or repairs. Electrical safety is a shared responsibility. Homeowners, contractors, and electricians all have a role to play in ensuring the safety of electrical systems. By following the NEC requirements and taking other safety precautions, everyone can help to prevent electrical accidents. Remember to consult with a qualified electrician for all electrical work. A qualified electrician has the knowledge and experience to install electrical systems safely and correctly. They can also help you to comply with all applicable codes and regulations. The Florida Building Code includes specific requirements for swimming pool electrical systems. The Florida Building Code adopts the NEC with some state-specific amendments. It is important to be aware of these amendments and to comply with all applicable requirements. The Florida Building Code also includes requirements for the energy efficiency of pool equipment, such as pumps and heaters. These requirements are designed to reduce energy consumption and save homeowners money on their utility bills. The Florida Building Code requires that all swimming pools be equipped with a safety barrier to prevent accidental drowning. The safety barrier must be at least 4 feet high and must have no openings that a child can climb through. The safety barrier must also be self-closing and self-latching. The Florida Building Code also includes requirements for the use of pool alarms. Pool alarms are designed to detect when someone enters the pool and to sound an alarm to alert nearby adults. The Florida Building Code specifies the types of pool alarms that are permitted and the requirements for their installation. Staying informed about the latest codes and regulations is crucial for maintaining a safe and enjoyable swimming pool environment. Remember to consult with your local building department or a qualified electrician to ensure full compliance. The NEC is a comprehensive set of standards for electrical safety. By following the NEC requirements and taking other safety precautions, you can minimize the risk of electrical hazards and create a safe environment for yourself and others. Remember that electrical work can be dangerous. If you are not comfortable working with electricity, hire a qualified electrician to do the work.